In this video, we are going to study properties of convolution. The first property of convolution is commutative property. In this commutative property, this can be represented for convolution integral as well as convolution sum. So for convolution integral, this property can be represented as, if we have the input signal x and if we convolve it with the system transfer function h of t, we get the desired output. So this commutative property says that we can interchange the position of these two terms and can be written as h of t convolving with x of t. Similarly, we can represent the equation for convolution sum as x of n convolving with h of n is equal to h of n convolving with x of n. Here we can interchange the positions of x and h in the equations of convolution. The second property of convolution is associative property. So in case of associative property, we consider two systems with the impulse response as h1 of t and h2 of t. These systems are connected in cascaded, that is in series. So let's say input applied to the system is x of t, output is y of t, and the output of first system is, let's say, w of t. Therefore, if we represent this in terms of convolution, we get y of t is equal to input to this h2 system is w of t convolving with h2 of t. But w of t is the output of first system. Therefore, it is given as x of t convolving with h1 of t. So if we substitute this in the first equation, we get y of t equal to, so w of t is replaced by x of t convolving with h1 of t convolving with h2 of t. So if we reorganize this equation and draw the corresponding system, we get the two cascaded systems h1 and h2 can be represented as a single system producing output y of t having applied with input x of t, and the impulse response of this system will be h1 of t convolving with h2 of t. Therefore, these two blocks are reduced to a single block and we get the desired output y of t. Similarly, if it is for convolution sum, this representation can be x of n with the system h1 of n convolving with h2 of n, and the output we have is y of n. Okay. Now the third property is distributive property. In this property, we are considering two systems are connected in parallel. These two cascaded systems are shown as shown over here. This h1 and h2 system is connected in parallel, and we have an adder block which adds the output of this system. Both the systems are applied with same input x of t. After the addition of the responses from h1 and h2, we get the desired output y of t. Therefore, this y of t is represented as x of t convolving with the inputs, but here we have the impulse responses of two inputs H1 and H2, and these impulse responses are added together, and if you look at the sign associated with these arrows, so here for H1 the size is plus, as well as for H2 the size is also the sign is also plus. Therefore this will be written as H1 of t plus H2 of t, because both H1 and H2 has plus sign associated with this adder block. So depending on this sign available to this adder block, you need to change the sign of H1 and H2. Therefore the simple simplified diagram will be, we will have applied input x of t. The parallel systems will be now simplified. We get H1 of t plus H2 of t, and we have the output y of t. So this is the distributive property for convolution integral. Similarly, we can have input x of n applied to a system. We have H1 of n plus H2 of n, and the output will be y of n. So these are the three important properties of convolution: commutative, associative, and distributive.